If this were released from rest, what will happen? One important thing to realize is that it says it's a frictionless surface. That's a huge factor here. So there's no friction on this ramp. So it could move. It might stay at rest. And we also don't exactly know which way it will move because you may think that the one that's not on a ramp, so it doesn't have any normal force perhaps, canceling out some of the gravity, that one will fall down and pull the other one up. However, that one's lighter. The capital M is heavier, actually much heavier. It's 4 times heavier. The masses are written there. So we're gonna have to do a little some calculations just to see which one's going to win, basically. All right, so let me start with I'll start with the small one because it looks a little simpler there. So lowercase m has got gravity pointing down, which I will label as mg, and then it's got tension. Now here's where it's tricky because, like I said, we don't really know which way it's going to move if it moves. So I don't really exactly know how long to draw that tension, but I'll just draw it about the same size, but I'm not going to put tick marks because I don't know if they're equal or not. All right. Some calculations here. So the gravity is 1 times 9.8, which is just 9.8 newtons. Okay, so I know how much force basically is trying to drive the system in one direction, in the direction where the lowercase m falls. Okay, so it's kind of pulling with 9.8 newtons, but this is going to be like a tug of war. On the other end of the rope, it's getting pulled the other way. The system's getting pulled the other way by this uppercase M, which now we have to apply some ramp skills here. So I'm going to draw this uppercase M at an angle. And it's got gravity. And what I'm going to do is break that down into components. So if I define some directions here, I have an x direction and a y direction. I break the gravity of uppercase M into those two components. So I'll label this capital M times G. That's the force of gravity, but the components are going to be mg cos theta for the y component and mg sine theta for the x component. Theta is 60 degrees. Those are our two formulas for the components of gravity for a box and a ramp. It's always going to be that. Okay, there's no friction. This is a frictionless ramp. There's a normal force. Now the normal force, this one is going to be the same magnitude as the y component of gravity because there's no motion in the perpendicular to the ramp direction. Okay, so then what I'm going to calculate is this mg sine theta component, the x component of gravity. So that'll be 4 times 9.8 times sine of 60 degrees. I was in radian mode, I gotta type this again in degrees mode. Okay, so I'm getting 33.9 newtons. So doing these little calculations, basically that compares the two tugging forces. So I got one tugging force at 9.8 newtons, and I got this other tugging force at 33.9 newtons. So that tells me which one's going to win. The big M's going to win. So that's going to slide down the ramp, and it's going to pull the lowercase m block up with it. I did forget to draw the tension, actually. All right. So now that I know that, maybe I'll go for a more informal approach for this one. I'm going to say treat the two objects as a single system. They are tied together. They're going to move together. I've kind of analyzed the forces that are influencing the system, so I'll treat the two objects as a system of mass. The mass would be the combination of 4 plus 1 kilograms, which is 5 kilograms. So if we think about it as a system, the net force on the system is going to be 33.9 minus 9.8. Those are the only two forces that are really trying to drive the system in one direction or the other. So I'll say then F net, the magnitude of it, on the system will be 33.9 newtons minus 9.8 newtons. What does that equal? 24.1, I believe. So then the acceleration by Newton's second law is net force divided by mass. So that'll be the 24.1 newtons divided by the 5 kilograms of total mass. Giving us, so I can divide by 5 here, right? So 4.82, but rounded to two significant digits will be 4.8 meters per second squared. So that's what will happen. They will accelerate at 4.8 meters per second squared with the capital M block sliding down the ramp and the lowercase m block being pulled upwards.